Hello everyone. Today we're going to solve the LeetCode problem number 33, search in rotated sorted array. So this is the problem. So basically we'll be given a rotated array and for a given target, so we have to return the index of the target. If the target is not there in the array, so we have to return -1. So this problem can easily solve in big O of n complexity, but here it's clearly stated that we have to design an algorithm so that it can be solved in big O of log n. So whenever we see big O of log n, basically directly comes to our mind is binary search. Let's look into the constraint here. So here the length of the array can be 5,000, and in array we can have negative and positive numbers. Nothing looks too scary here. So how we're going to solve this problem using binary search? So let's say we have a array of length 7 and we are going to rotate the array at index 3. So after rotating the array, so it is going to look like this array in the right hand side. Now we can see the whole rotated array can be divided into two sorted parts, part 1 and then part 2. So how we're going to solve this problem? So in this normal binary search, right? The complete array is sorted, but here we have two different sorted part. But you can say that part 1 is sorted, part 2 is sorted, so we can say that at any point of binary search, so one half will always going to be sorted, right? So in binary search, as we have like low, mid and high, so based as this is sorted, right, we can have three scenarios: low and high both in the first sorted part. The second scenario can be like low and high both in second sorted part. And the third scenario is like low and high in different parts, right? So, but instead of like handling all three scenarios, we can like smartly handle them in three scenarios, two scenarios. Okay. So here you can say like the key observation is like if number nums of low is less than or equal to numbers of mid, so we can say that the left half is sorted, right? uh, Else you can say that right half is sorted, and that is the trick to solve this problem. So let's take a case one when we can say is left half is sorted. So in this scenario, so we are going to have like number nums of low is less than or equal to nums of mid. So at this scenario, so we can check like whether target is left of the left side of the mid or not, right? So how we can check like whether target is in the left of the mid or not? So it's directly we can check like target should be right greater than of numbers of low, right? Because left side is sorted, and after that like target should be less than mid, right? So if this scenario satisfy, if this condition satisfy, we can go to left. Else, like we can move to right. Let's look into the case two when right part is sorted. So whenever right part is sorted, we are going to have like nums of low should be greater than nums of mid. So in this scenario, whenever nums of target is greater than nums of mid and target is less than or equal to nums of high, we have to move uh, towards right from the midpoint. Else, like we have to move towards left. And this is the intuition behind the solution. Let's jump into the code. So this is the Java code for the solution. So I have a basic binary search while loop here, and inside the while loop you can see like I have three condition. One condition like I'm checking like whether I have found the target value against the mid index or not. If I'm finding it, so I'm returning the mid. Else like I'm checking like whether left side of the array is sorted or not, whether right side of the sorted array is sorted or not. So while iterating to the loop, if I'm fine, the target value I'm returning it, else like I'm returning -1 in the end of the function. And this is kind of like very simple implementation of the solution. I think that's it for today. If you find this video helpful, don't forget to like and subscribe to my channel. See you in the next video.